Rahim. Dear student, before this we studied about the de-limit principle, virtual work, principle of virtual work, and after that the topic was basically Lagrange equation you can derive from de-limit principle. But before Lagrange equation, the problem is about the Lagrange equation is first a simple pendulum. As you know, the simple pendulum is if a small bob is attached to any extensible string and is allowed, if you disturb it and is allowed to move freely, then it will give us a simple harmonic motion. But here you see that this is the length of pendulum and this is the mass which is being attached initially. And the length of the pendulum is L. Length of pendulum is L. Now, if the pendulum is displaced through a small angle theta, here you see the weight mg is also making angle theta. So, in this case, we have two components. How much components are? Two components of the weight. One is mg cos theta, which is lying along the string, and the second one is mg sin theta, this one. How many components? Here we get two components. One is mg cos theta and the second one is mg sin theta. Now, due to mg sin theta, if you allow this bob, due to mg sin theta, this pendulum will oscillate. Mg cos theta is balanced by the tension T which is in string. Here the tension T in normal here, these are the constraint of forces. These are the constraint of forces. जिस तरह की मैंने लिखा है कि suppose the pendulum oscillate under a constraint. Constraint means that here you see normal is also constrained to this pendulum, tension T is also constrained to this pendulum, and length is inextensible. If you use extensible length, then it will increase the time period or it will change the frequency and so on. So, length will be fixed, and what is the tension T? Normal. These are the constraint of force in this case. And again you see that we have 1 degree of freedom or one generalized coordinates. Is already I told you, in case of simple pendulum, for example, this you take, this is x component, this is y component, here two components, you see two components. But here again you see theta. Generalized coordinates means it is the minimum number of coordinates which can explain the state of a system easily. So, you can easily explain this with the angle theta instead of x and y. X, y, here you have two components, two coordinates, and here you have single one. So, that is why we are taking the generalized coordinate theta here, that is 1 in case of simple pendulum, and his 1 generalized coordinates. Now, if the bob oscillates, it will have kinetic energy as well as potential energy. What will be the kinetic energy? 1/2 m square or 1/2 m, instead V is equal to R theta dot. Theta dot आपके पास जो है, यानी here you are putting the value V is equal to L theta. If you see S is equal to R theta, but V is equal to R theta dot. Here instead of R, here you see we have L and this is theta dot. So putting the value of V here, 1/2 m L theta dot whole square. RT becomes 1/2 m L square theta dot square. Suppose this is equation number 1. This is the kinetic energy in this case. Now to see the potential energy V is equal to mg into L minus L cos theta. Total length of the pendulum is L, and how much it is being raised, this one, and this is L. Here you see this is L cos theta, and this one is L. So this portion or this interval will become L minus L cos theta. That is why here V is equal to mg into L minus L cos theta. L minus L cos theta. यानी इस लेंथ के अगर आप कंपोनेंट ले लें तो ये बेस है, ये L cos थीटा के बराबर होगा और ये L sin थीटा के बराबर होगा. So potential energy is V is equal to mg into L minus L cos theta, while kinetic energy is 1/2 m L square theta dot square. So Lagrangian is nothing but it is the effective value between T and V, or it is the difference between kinetic energy and potential energy. Kinetic energy is 1/2 m L theta dot square, and potential energy is minus mg into L minus L cos theta. Lagrange equation for the coordinate theta is, इसको इंशाल्लाह कल हम प्रूव करेंगे. d by dt delta L divided by del theta dot minus delta L divided by del theta is equal to 0. This is the Lagrange equation for theta. अगर in term of x लिखें तो ये x dot होगा, ये x होगा. अगर in term of q लिखें जनरलाइज कोऑर्डिनेट की शक्ल में तो q dot और q होगा. आपने इस Lagrange इक्वेशन को किस शक्ल में लिखना है in term of थीटा, तो ये del L divided by del थीटा डॉट माइनस del L divided by del थीटा इज इक्वल टू 0. या इसको आप डिफ्रेंशिएट करें del over del थीटा डॉट को, इसको तो आप देखेंगे कि आपके पास ये आ जाएगा 1/2. तो आपके पास ऑलरेडी है. और दूसरा जो है 1/2 मल्टीप्लाइड बाई 2m L स्क्वायर थीटा डॉट प्लस mg इंटू L साइन थीटा, यानी ये कांस्टेंट वैल्यू है और इसकी वो आ जाएगी cos थीटा माइनस साइन थीटा के बराबर है, तो mg इंटू L साइन थीटा इज इक्वल टू 0. अच्छा, तो ये गोया इसी केस में आ जाएगा m L स्क्वायर थीटा डबल डॉट, ये कैंसिल हो जाएगा, इज इक्वल टू माइनस mg L साइन थीटा, या थीटा डबल डॉट इज इक्वल टू L कैंसिल करें सिर्फ यह आ जाएगा माइनस g बाई L sin theta. For small theta we take sin theta is approximately theta. अगर इसका एक्सपेंशन ले लें तो फर्स्ट टर्म जो है थीटा के बराबर आएगा, तो थीटा डबल डॉट इज इक्वल टू माइनस जी बाई एल थीटा, इसकी जगह क्या आ जाएगा, थीटा आ जाएगा, जो कि ऑलरेडी आपसे मांगा गया है. फॉर सिंपल पेंडुलम यूजिंग Lagrange इक्वेशन शो दैट थीटा डबल डॉट इज इक्वल टू माइनस जी बाई एल इंटू थीटा. थैंक यू.